Carboxylic acids are hydrocarbons with a carboxyl functional group. They have the general formula R, which is your hydrocarbon, then COOH. It's not necessary to put the O or the OH in brackets when doing expanded molecular formulas. Naming carboxylic acids. You follow the hydrocarbon rules and you drop the E of the parent name and use the suffix oic acid. Carboxylic groups take numbering priority over any alkyl groups, but they do not take numbering priority over double or triple bonds. Usually you do not need to put a position number for the carboxyl group because it will be on carbon number 1. Here are some examples. For molecule A, my parent chain are those two carbons, so I get the root eth, and because they're single bonds, ane. Now I would drop the E and then add the suffix oic acid in order to indicate the carboxyl functional group. So the name for molecule A is ethanoic acid. For molecule B, my parent chain must include the double bond. And it must get the lowest number. If I start numbering my parent chain from left to right, it gives the double bond a position of carbon number 2. If I start from the right to left, my double bond also gets position number 2, but then my carboxyl group will get a lower number. Because I have 4 carbons in my main chain, my root is going to be bute. To indicate the position of the double bond, I have a 2-ene. Then, in order to indicate my carboxyl functional group, I would add the suffix oic acid. So the final name for molecule B is bute 2-ene oic acid. Properties of carboxylic acids. The carboxyl functional group has multiple intermolecular forces. It can make a dipole-dipole off of the C double bonded O, and it can also make a hydrogen bond off the COH. Both of these forces increases the melting point of the molecule compared to an alkane. In terms of solubility in water, the OH group can make a hydrogen bond with water, and the C double bonded O can accept a hydrogen bond from water. Both of these intermolecular forces gives a carboxylic acid a higher solubility than an alkane. Other information about carboxylic acids. They often have an unpleasant smell. For example, butanoic acid is the smell that you get from vomit. So I always try to avoid working with that one in the lab. Carboxylic acids are weak Bronson-Lowry acids. Only the H from the hydroxyl group can be donated because of its polarity. Now because this is a weak acid, the H only falls off part of the time. Let's look at the structure of the carboxylic group. In terms of polarity, O is stronger than carbon, and it's stronger than hydrogen. So you get these partial charges. Because this is an OH group, this is a very strong, slightly negative charge. And this is a very strong, slightly positive. Because the hydrogen does not get the electrons a lot, this bond is very weak, and the hydrogen can be donated to a base. Now the electron is kept by the oxygen, which will make this a full 1- charge and change the hydrogen to be a 1+ that gets donated. Carboxylic acids behave like all the other acids we talked about in previous courses. They turn litmus red. They do neutralization reactions with bases. They are clear in phenolphthalein. And they have pHs below 7.